Today we're going to be learning about ordered pairs, which for the most part is a review for you, but we're going to be tying it into the things that we're going to be talking about in this unit. So let's start with a question. List all possible combinations of x and y numbers such that x plus y equals 3. Now I'm going to give you an example, and then I want you to pause the video and see how many you can come up with. The first one that I'm going to give you is, what if x equals 3 and y equals 0? Then do you agree that 3 plus 0 equals 3? I do. Okay, so now your job is to pause the video and come up with as many as you can. Well, hopefully you came up with quite a few. Let's just list a few. X equals 2, y equals 1. We could even reverse that. X equals 1, y equals 2. Now some of you may think that we're out of options, but what about x equals negative 2 and y equals 5? So there's nothing that said it couldn't be positives and negatives. What about, x equals negative 994 and y equals 997. Would that also equal 3? So my question is, and the reason why I threw up that last one is, could we keep going on this forever? What about x equals 2.5 and y equals 0.5? Would that add up to 3? So we've got lots of different numbers here that would work. I mean, let's throw on another one as long as we're at it. X equals, how about a fraction? Let's do x equals 3 over 2, which is 1.5 in case you're wondering, and y equals also 3 over 2, also 1.5. 1.5 plus 1.5 is 3. So that would also equal 3. My question to you now is, can they be the same number? Well, yeah, they can. Okay, so we're going to use this for our discovery lesson today of the different parts, or the different things that relate to ordered pairs. So first, what is an ordered pair? An ordered pair is just a fast way to write one pair of numbers together. Back here on this example, we were writing x equals y equals a comma. Now, did it take a long time? Probably not. It didn't take me very long, but a faster way to do it is just to assume that, hey, we put these parentheses, we always put the x first, then we put the y, and if we just always know that the x comes before the y, then we've got our ordered pair, and it is a little bit faster. So what will that look like? So instead of writing x equals 3 and y equals 0, I can just write 3, 0. Now, you have to have the parentheses, you have to have the comma, but it is the same thing. It saved me a little bit of writing. Not a ton, but a little bit. So these numbers right here all add up to 3. They're still with the same problem. X plus y equals 3. So let's write some ordered pairs. I'm going to take this first one right here, and I'm going to write it here. So first comes x. So I'm going to put my parenthesis, then I'm going to put a 2, then I put a comma, 1, and then a parenthesis. Okay, my second ordered pair right here is going to be parenthesis, negative 2, comma, 5, parenthesis. My next ordered pair here is going to be 4, comma, negative 1, parenthesis. Now the last one, if you look at it, do you see how the x and the y are backwards? So don't get tripped up on that one. So first I'm going to write 6, and then I'm going to write negative 3. So now I have all of my ordered pairs written, or all of my pairs of numbers written as ordered pairs. And it did save me a little bit of time. I didn't have to write the x equals and a y equals. So what else can we do? What's a table? Not the type that you eat dinner at. So a table is a fast way to write lots of pairs of numbers together. So now I've got my ordered pairs over here. How can I put them in a table? Well, it says that my x goes first and my y goes second. So what I'm going to do is I'm going to take my x value first, and then I'm going to take my y value second. So 3, 0, and they do need to be across from one another. So if I continue on, I'm going to start with the negative 2, 5. I'm going to say negative 2, and across from that would go 5. Then I'm going to have my 4 and my negative 1. Next, I will put negative 3 and 6. Finally, I'll go to my last one, and I would have 2 and 1. So my question is, do you see a pattern? So if I'm looking at that, okay, let's try to find a pattern here. First, I could say, well, that's going up by 5. That one's going up by 7. That one's going down by 5. I don't really see a pattern. Hopefully, maybe you're smarter than me and you were able to figure something out, but I don't see one. The whole purpose of what we're doing with a table is we want to find patterns. And so we've got to come up with a better way to write our table so that we can find a pattern, because guess what? There's a pattern. So let's look at this. I've got my original table right over here. This is the original right here that we just finished. So what we're going to do so that we can have a little bit of help finding patterns is we want to put the X numbers in order. Now, the Y numbers still have to match. So what we do is we find the smallest X number, which in this case is negative 3, and I'm going to write it first. Negative 3, across from that has to go 6. I'm not putting the X's and the Y's in order. I'm just putting the X's in order. Okay, after I do that, my next one is going to be negative 2 and 5. Okay, after I complete that, I'm going to go ahead and cross them off so I don't get confused. Okay, so the next one that we're going to do, if I'm looking at my numbers, the small one is going to be 2 and then 1. And then next I would have 3, 0. And finally I'd have 4, negative 1. So let's see if we find a pattern. So if I look right here, that one is going down 1. This one is going down 4. This one is going down 1, and this one is going down 1. So I did find a pattern in quite a few of them. Let's look on the other side. This one is going, what is that? From negative 3 to negative 2. Is that up 1 or down 1? It's actually going up 1. What's happening here? That one's going up 4. This one's going up 1, and this one's going up 1. So where I didn't find a pattern on the one before, now that I put it in order, I do see a pattern there. Now there is a jump right here where it's got this negative 4 and positive 4, but hopefully you realize that we also jumped some numbers. Are there any numbers between negative 2 and 2? Yeah, there's a negative 1, there's a 0, there's a 1, so there's lots of numbers that could fit in there. But the fact of the matter is, when I put it in order, I found a pattern. So let's think about all the pairs of numbers that we had. And we were just looking at these right here. We had 3, 0, we had negative 2, 5, 4, negative 1, negative 3, 6, 2, 1. And then at the beginning, I also had some crazy ones. I had some decimals right here. I had some big numbers here. I had some fractions here. So my question is, did I miss any numbers? Or did I write down every single number that there was? Did I write down every single negative there was? Did I write down every single fraction that would add up to 3? How about all the decimals that added up to 3? How about all the huge numbers that add up to 3? No, I only had one example of huge numbers right here. I only had one example of decimals. I only had one example of fractions. Do you think there's other big numbers, fractions, decimals? How about I only had one example of positives and negatives that would add up to 3? Do you think there's a lot more numbers that would add up to 3? Hopefully right now you're saying to yourself, well, yeah. So our question now is, how do we show all the numbers that add up to 3? Well, let's talk about the next thing. It's a graph. Okay, so a graph is a fast way to write all pairs of numbers together. So what does a graph look like? You've seen them before. They look like this. Some of you are either rejoicing right now because you're thinking, oh, I can graph dots, or oh, I can graph those fun pictures, and some of you are probably like, oh, I'm going to have to graph. whatever your response may be, we're going to learn about graphs now. So what is a graph? First, let's look at this graph here, and we're going to break it apart a little bit. If I take this little red section here, and I've got it outlined already, but if I enlarge it, this becomes, and some of you remember the word from 8th grade, it's called quadrant, and I'm running out of room, 1. Okay, this is quadrant 1. That is where all the numbers are going to be positive. A few more things about the graph. We have where we start every time. It's called the origin. Where I like to say that that's where the graph originates. That's where we're going to start every single graph that we make. We always start at the origin. What is the ordered pair? Well, the x value is 0 and the y value is 0. So the ordered pair is 0, 0. So this is the point 0, 0 on the quadrant 1. This is the point 0, 0 on the full graph. So x-axis. So this is my x-axis. It's the horizontal one. It's the same thing, but remember I've just got the enlarged quadrant 1 right here. I'm just going to abbreviate it like this, quadrant 1. We'll put a Roman numeral there. Okay, so positives go right, negatives go left. Okay, it's just like a number line. You've seen number lines before where you have a 0 in the middle, then you have 1 and 2. When you go backwards, you have -1 and -2. So this is what graphs look like. They actually have the ordered pairs and they follow just what you already know. They're going to follow positives and negatives. Okay, we have our y-axis. So y-axis is a little bit new. It's not the same. We're going to go up for positive and down for negative. So think about digging down under the ground would be negative. Okay. Next up, how do I graph the ordered pair 3, 0? So I'm going to first go to my quadrant 1. I always start at 0, 0, and this is telling me I'm going to go on my x-axis 3. So I like to draw a little loop-de-loos, but I'm doing it with my fingers, so I hope it works out. So 1, 2, 3. Okay, so right there, and then it says y is 0. So going up, I'm not going to go anywhere. So my dot would be right there. And I'm going to make it red so it can kind of stand out. But I went over 1, 2, 3, and then I stopped. Okay, how do I graph it on the big graph? Well, I still start at 0, 0. I'm going to go over 1, 2, 3. And then I'm going to not go up any, so it stops right there at 3, 0. So when you see an ordered pair, I'm going to draw it down here. It's x and then y. I like to draw a little picture on here. This is my left, right. Y is my up, down. If you need further help, you can add a negative on this side and a positive on this side, and a negative and a positive. So let's do these 3 ordered pairs, or these, I guess there's 5 of them, 5 ordered pairs. We already graphed 3, 0, so I am just going to put the dot right there and cross it off. Next, I'm going to graph -2, 5. So -2, I'm going to start at 0, 0, and I'm going to go backwards 1, 2. And then since it says +5 for y, I'm going to go, if you look right here, that means I'm going to go up 5. 1, 2, 3, 4, 5. And I'm going to put a dot. Now I'm going to do a little erasing because this is going to get really messy. And it was -2, 5, which was right there. Okay, let's go ahead and label these. This one's 3, 0. This one is -2, 5. Okay, next I am going to graph 4, -1. So I'm going to go over 1, 2, 3, 4, and then I kind of missed my line because once again I'm doing with my fingers, so but I should be up here right now, and then I'm going to go down 1. Okay, so 4, -1. Maybe I should try that again if you were a little confused. 1, 2, 3, 4, not much better, but down 1 for my dot. Okay, so my dot would be right there, 4, -1. Next, I'm going to graph -3, 6. So I'm going to go backwards. 1, 2, 3. Why did I go backwards? Because it was negative. Then I'm going to go +6. 1, 2, 3, 4, 5, 6. Okay, so my dot would be right there. -3, 6. Okay, and finally, my last one is 2, 1. So I'm going to go over 2, up 1. So it would be right there. I know that was beautiful, but my dot is right there. So 2, 1. Look at those dots. Now I'm going to do something. I'm going to erase this so you can just see the dots. And I want you to see, do you see a pattern? We were talking about patterns a minute ago on the table, but do you see a pattern on the graph? Hopefully right now some of you are saying, oh, wait a minute, I see a line. So the question is, how do I show all of the answers for x plus y equals 3? Well, I draw a line, because guess what's at the end of the line? An arrow. That means it keeps going. Guess what's at the end of this line? An arrow. It keeps going. So now I did not hit my dots very well. I tried. So what we're going to do is we're going to grab this dot right here. It's on the line. So that ordered pair would be over 1 up 2. So 1, 2. Does that add up to 3? Is 1 plus 2 3? Yeah, it is. Okay, sorry about my child in the background. Okay, next, how about this dot right here? That dot is 0, 3. Is 0 plus 3 going to be 3? Yeah, it is. How about this dot right here? That one would be 5, negative 2. Is 5 plus negative 2 3? Yes. Okay, could we also talk about decimals? A minute ago I said that 2.5 and 0.5 added up to be 3. So let's go over 1, 2 and a half, and then up 0.5. Hey, that would be about right there. Granted, remember I'm doing this with my finger, so hey, that's right there on the line. I also said 3 halves and 3 halves, which was 1 and a half, 1 and a half. So over 1 and 1 half, up 1 and a half. Hey, right there, it's on the line. Okay, so anyway, how do we show all of the answers for the equation x plus y equals 3? We draw a line, because every single dot on this line, every single one of them, is an answer to the problem. I'm going to give you a little bit of help on your level 3 problem. You're going to be looking for average speed. Now usually when we talk about average, we're saying, oh, well, if I want to find the average of something, I'm going to add a bunch of numbers together, and I'm going to divide by how many numbers there are. And that is average. But if I were to find the average speed of this first, what is speed? Well, speed is distance divided by time. Okay, so we have distance and time. So let's just find the speed in one section on here. How about the last section where Jack and Jill, and this is talking about Jack and Jill going up the hill. We're going to talk about the speed in the last section, because they're both together on that one. So if I did the speed, my distance is from there to there, which is from 1400 to 1600, which is 200 feet. And I'm going to divide it by the time it took them to do that. Okay, so the time, I have to look down here, that's from 18 to 20, which is 2 minutes. Okay, so distance divided by time would be 100 feet per minute. Okay, so that's how you get speed, distance divided by time. So my question to you is, on average speed, do you think I would find the speed here, and the speed here, and the speed here, and here, and here, and add them all up and divide by how many sections there are? No, I'm not going to. And the reason why is I want to actually find the speed from the beginning of the trip to the end of this trip. So let's just look at Jack, because Jack is the dotted line, and that seems like the easiest one to me right now. Okay, Jack is going from here to here. So how far did he go? What was his total distance? Well, he went from 0 to 1600. So he went 1600 feet. How long did it take him to go there? Well, he went from 0 to 20. So 1600 divided by 20, let's see, and this is minutes, is going to be 80 feet per minute. So when you're finding average, you're going from the beginning to the end. You're not going to take all of the little sections in the middle and divide them by how many sections there are, just beginning to end. Hopefully that will help you with your level 3.